My name is Nnenna Ndukwe, and I am excited to talk about this. I've been sort of experimenting, so hopefully there'll be even better versions of this in the future, but the idea of the separation of agentic concerns. For those who are super into AI and AI agents, the concept and software engineering, the actual concept itself isn't new, it's just a different way that I'm looking at the direction that the tools and technologies are going in for AI, for engineering. So a little bit about me. Like I said, I'm Nnenna. I really am into all things Gen AI and AI. Before that, I was traditional software engineer, software developer. But throughout my career, I was always doing things that were DevRel or developer relations adjacent. And so I officially made that transition a few years ago and recently joined Codo, where I get to actually be paid to be obsessed with AI as much as I am. So very happy about that. And my focus has been AI for software development, just really thinking about the type of workflows that we have as developers without AI and how we can then integrate AI in a way that works for us for productivity. And yeah. So I want to start with this tweet that I saw, and I had to screenshot it because I thought it was an interesting topic and a great case for an entire presentation. If the agent can write the code, it can review the code. We're all using the same models. I don't understand what code review bots are selling beyond prompts and some GitHub Actions glue. I probably should have asked a question earlier, but raise your hand if you agree with this person. Are you guys doing this on purpose? Is this like a devil's advocate thing? No, I'm kidding. I appreciate that. I thought that was a very interesting topic. It kind of let me know that there are folks who understand how AI works, who understand how LLMs work, and are thinking, why not have all of these use cases under one umbrella, and let it be what it is instead of separating all of these different functions or phases in software development, which is what I would call like one AI to rule them all. It doesn't mean it's literally one AI, but that's kind of how you can perceive it based off of that tweet if we want to follow it. So what would that look like? A single agent that can handle all the aspects or many of the phases of the software development lifecycle, which includes planning, coding, testing, deployment, and where you can just quickly describe what you want and AI can do it. Kind of sounds like vibe coding, honestly. And this is definitely vibe coding, or that kind of concept is something that is pushed heavily in the market right now. And it's all about simplifying the process of building software, which has incredible use cases, right? And I'm sure there are many vibe coders in the room, even if we have the technical skills and are using that to build software as well. So this sounds really ideal for one AI to actually rule them all. By the way, I am a huge Lord of the Rings fan, so I was very intentional about that name. And if you are one too, we should talk afterward. But my answer to this interesting question, why not have one AI do it all? You can, but it depends on what your goals are. So if we think about speed, maybe that is one of the best use cases for one AI tool or one AI for coding to handle many phases of the software development lifecycle. But if we're thinking about quality as well, and it's not just a side project, maybe you're an open source maintainer, maybe you're working in the enterprise on an actual engineering team, and you're allowed to use AI tools, or that's being introduced and you're using it, but there has to be done in a more structured way, because the quality of your work, the expectations that were there before AI was introduced, will still exist after AI is introduced. So how do you balance that when you're thinking about velocity, productivity, speed, quality? That's why I say that maybe you shouldn't use the same agent for writing and reviewing the code and other phases, because the cognitive architecture requires specialized frameworks where AI systems need distinct cognitive modes to optimize for generative creativity versus analytical fault finding. We can go through this slide, but pretty quickly, what we see here are really the problems of what can happen when we're utilizing this general AI coding tool for many phases of the life cycle. We're seeing issues and critical vulnerabilities in production. We're seeing some duplicated code blocks. I know 2024 in AI years is a long time ago, but that's still something to think about and consider. We're seeing that 25% of developers report 1 in 5 AI suggestions contain some functional errors. And there's a code quality degradation that happens, and that's not improving. Now, these are stats I pulled from different sources, and one of those being GitClear as Codo's State of AI Code Quality Research, and it talks a lot about how there's an erosion of code quality. So when you are an engineer and there are expectations of actually building high quality software, we're starting to run into issues. And that's why in my answer that I believe that separation, or did you want to take a picture of that? That's why I believe that the separation is where we can actually get the best of AI agents when they actually have specialized focuses. And the fundamental problem with general purpose AI coding, these are some of the problems, and there are many, is the context window limitations, or the issue with context in general is a huge topic of conversation. How to think about like optimizing for code generation versus optimizing for review. Those are going to clash, and those are very different ways of approaching code. And then, of course, the non-deterministic behavior, specialized guardrail, when you don't have specialized guardrails, and this idea of if you have a general purpose AI coding agents, that it's kind of like a jack of all trades, but not really a master of none. So this made me think, okay, let me go back to the drawing board. Let me go back to this software engineering mindset and our experiences over the years. We've spent 15 years learning that monolithic architectures don't always scale based on your needs. And that's how microservices were introduced as a solution. So that made me think, what about AI agents? What if we were to think with that mindset, but apply that to AI agents? And would we maybe then solve for some of these problems that we're seeing with using these general purpose AI agents? And that is what brought about this really long answer, this much longer answer to the tweet that I only kept for myself in these slides. And that I think that context is cognitive architecture. So when you sit down and you're writing a feature, right, versus when you sit down to write tests for that feature, those are completely different mental models that you are leveraging. Very different patterns, even with named methodologies that you are leveraging for each of those phases, and different problem-solving approaches. So if those are completely different ways of approaching your code, that shows that each phase or each part of the work that you're doing, you are optimizing your own mind or shifting your own mindset to be able to complete that phase successfully or up to a certain standard that would be required to have quality in your code. And I think that that can be true for AI systems as well. So when we give an LLM the context of write production-ready code that handles edge cases gracefully, that is a completely different pathway than if you prompt it with find every possible way that code could fail and write comprehensive tests. So the model isn't just predicting the next token, it's predicting the next token given the specific framework that you have established. That's why I call it the separation of agentic concerns, because I think it's a separation of cognitive concerns, right? We can apply how we think and approach problem solving, and then think about, are we asking AI to do something totally different? Maybe we can actually start first with having AI replicate the way that we would approach problem solving in our own brains. And I think that that's part of what makes the case for multi-agent systems. Instead of one agent or one simplistic system that's dumped into the very complex and multi-step process of the software development lifecycle. So the separation of concerns. I remember first learning about this when I was learning about web development, really. I was in a coding boot camp, and my engineering instructor told me about explain the difference between HTML code and CSS, and how it's important that there's a separation of concerns with the way in which you write code. Because if you want, you can have your styling be a part of your HTML, but when we were first learning how to code, it was important for us to be able to separate those mindsets. And styling is specifically for CSS in a CSS file. Don't try to converge the two or have them mixed up where you have your CSS in HTML files, which you can do. So that's the mindset that or a principle, that I then wanted to think about how can we apply that to AI. Planning agents will be different from coding agents, will be different from review agents, and the result could be an overall better architecture when the goal is code quality for production grade systems. So simple software, AI for code generation, this might be all that you need, but for more complex software, there are multiple considerations that make up this framework of what is code quality. And that includes maintainability, reliability, compliance, standards that might be on your team, or standards that might be, across your engineering org, and a whole review phase. So those are multiple aspects of what makes up code quality, not just the code generation aspect of what it means to actually do software development. Here's the traditional software development lifecycle. And this is kind of as far as my brain went with, okay, but now we just need to inject it with AI here. You got the picture? Awesome, okay. So here's how I think about inject with AI, is if we already have a software development lifecycle, we know there's so many different diagrams that we can use, but now let's just plug in AI into those specific phases. If we have an AI planning phase, or an AI planning system, an AI planning agent, that could take your Jira ticket, or whichever project management software tool that you use, and reference that in your IDE, or wherever it is that you code, to then begin planning how you're going to implement this product requirements, or tasks, the breakdown, plan how I'm gonna implement this. That would be the AI planning phase. Then we move on to the code generation phase. You can think about, now that we've planned it, now we have what we wanna do, let's implement it. Or let's implement phase 1 and 2 and 3. And you can have the testing aspect of it mixed in there however you think, if you're test first development, if you're a test driven development, it all depends. Then when you move on to the code review, you can do or apply code review, whether it's locally in your IDE, which there are tools, including Coder right now, that does provide code review locally before you actually submit a pull request and review it in GitHub. The point is that there is an AI for the code review phase, completely different phase that is required functionality from the code generation phase. And then you can take a step back and look at the bigger picture of, okay, there needs to be workflows, not just being able to complete these tasks within the phases, but overall workflows, if there's anything that's repetitive or something that's important to apply to actually part of your team, for example, generating docs along with the tasks that you're working on, or ensuring that best practices that you've already established on your team can be applied, then there would be some workflows around your code integrity. And then beyond that, or maybe below that, would be the context that would be important for powering all these other phases, the phases above it, for software development, which would include agents, it could include MCPs, and in this case with Codo, which I'll get into in a slide, context engine. So I kind of already went over this. We've got specialized agents for more holistic and more high quality end-to-end developer experience. This is the approach that we leverage at Codo, and this is the approach that many tools in the industry right now or in the market are starting to pick up on. It is going to ultimately be about how do you converge or how do you integrate all of the different tools that you want to use or different AI systems that you want to use to make sure that it flows and can at least match or improve the workflow that you already have without AI at all. And this is a little side quest I wanted to talk about, which is the context engine. So we have the multiple agents doing all the things that we needed to do, but then we have the other systems, or the underlying systems that can directly impact and improve the actual agents that you're using across the software development lifecycle. And that's why I added this slide, is that knowing when something can be an agent and when something needs to be actually an entirely different underlying AI system that will power the agents with more. So most AI tools can read the code, but I think that this is more about understanding the code over time. I have seen a lot of conversations about context engineering, and I think it's really exciting that we're trying to solve for this problem of context, but I'm also a little worried about how much pressure we're putting on developers to understand all aspects of context engineering and then implement it themselves just to get really high quality results, right? If our agents can only do so much, how are we then now supposed to know the exact way to leverage context in the specific tools that you're using? What if so in that case, when I see something like that, I immediately think, well, then there should be a system built that handles that for developers. Now, I'm not saying that this does that completely without any, without a developer's interaction or a human in the loop, but what I'm saying is knowing when to create an actual separate system that can solve the problems that are coming up, then I think that we're onto something with actually maturing what AI architecture can look like for software engineering. And this is a context engine that's going to connect through flexible MCPs and APIs, and it's going to embed deep code-based intelligence into your IDE, into your terminals, into your AI workflows, the workflows that I mentioned in the previous slides, so that all of those agents that have their different duties and specializations, the output can improve over time. I like to think about it like this context engine that is running, and there's running like a code-based indexing, and every night maybe it builds, and so that every time that you actually are getting responses from your agents or expecting a certain type of output, it can learn from what you are giving a green light to. It can learn what you're accepting for your code in the code generation phase. It can learn what you are approving when you are getting the results from your AI code review tool. And so if those are, and then you mix all of that in with the team standards, then you get a system or systems that improve over time. So I think that's part of knowing when to, this is my side quest of knowing when to attack something from we need an agent for it. And this is actually a very complex problem that we could probably build an entire system or engine for it. And we can quickly go through how I like to think about the phases. I kind of think about like, okay, we've got the planning agents. This would be the strategic thinking before the coding phase. And so this would be the phase where you can analyze the requirements that you're given or that you have, and you can break down the complex tasks. Then you can evaluate the architectural approaches and then create sort of an execution blueprint. This is the plan before act aspect that we see many tools are starting to leverage more and more. And the fact that this didn't initially exist, but now it does in some of our AI coding tools shows that we are really experimenting closer. I think we're going to get closer to making it very clear that the way in which that we separate the life cycle right, is the way in which that we can separate the modes or the systems of agents that we are using. And here's the second step. This is very simplified, by the way, on purpose. The coding agent for just the focused execution within certain guardrails. And based off of the pre-approved plan that you had from the planning phase, then you can generate the code for like the implementation. And it could be specialized maybe by domain, if that's front end, back end, security, performance, and it can communicate through shared state, not just direct messaging. So this is meant to, again, emphasize the specialization. And we have this for write and run tests and debug. I kept it very general because, like I said, everyone's software methodologies are different based on your different teams, where and when you run your build and run and tests. And then we have the review phase. This is all about enforcing the code quality standards. This is your own QA before an actual QA engineer gets a hold of anything. So the review agents can focus on quality and style consistency, and maybe there are other aspects like security that can be a focus. Maybe I think that should probably also be another separate system or something that you integrate using other tools like Sneak, MCP, for example. And this is a part where you can identify duplicated code patterns or prevent quality degradation over the iterations of the code. So review agents are meant to catch errors that the coding agents have introduced. And that can really help to break that vicious cycle of iterative degradation, which has been a big concern, has been documented. And for reference, 44% of developers blame context issues on quality degradation, and 40% cite inconsistency with team standards, right? So when we are presenting or when we are leveraging different agents that are going to be checking for completely different or slightly different standards or focuses, then I think we're creating a process where we are increasing the chances of improving the quality or catching any issues that would have come up from any of the earlier phases. So why does this matter? I think this is more than just a code base. As I mentioned, team standards, I mentioned the engineering organizations. I think that AI-generated code today, there are a lot of issues that we can solve if we start to think about the software development lifecycle, if we start to think about the ways in which we've separated aspects of our work and then apply that same concept, or separated the way in which we work, apply that same context to the actual systems that we're building and then how we're using those systems. And that could result in improvement in quality. It could result in a reduction in technical debt and understanding these more sophisticated architectural patterns that can scale over time beyond the simple AI code gen and vibe coding. And that's it.